Hey there, this is Loudon Gaming, and I am back with my sand simulator. Last episode, we created water and walls, and I thought I would add maybe some lava, and we'll see what else we get to, how long it takes, and whether or not maybe we could add some gas particles as well. So I did kind of add this little text up here so that I can know when I'm changing between the different elements, I guess, or particles I'm working with. So we'll just show that real quick. So now it says sand, and I can lay the sand down. We got water now. And I also fixed the sand particles so that uh, they actually stack up in the water. I just had to check for that, check for those diagonals if it was in water or, but anyways, that's that. So let's get to the lava. So I have a script called lava, and we'll get rid of all this. And what I'm thinking is we're going to just try this. It might just be able to inherit from water because it's basically the same thing, right? Let's do let's get rid of this little red squiggly line. So we got that construct. We're going to say color is equal to color.red. And the cell type, so I have to go here and add that. Again, kind of annoying. You want this to be a little bit more automatic, but oh well. And then we were going to say cell type is equal to lava. Yeah. All right. I think that's it. Let me go back to the cell. We don't need the sink anymore, but what we might want is, I don't know, flammable is can burn. And we'll just say everything can burn for now. True. All right. So go back to lava. And actually, yeah, we'll just say everything's true for now. What do we want to do? So it already has, if we go to our uh, override our activate, and we're actually going to leave the base activate. So the base right now would be the water for it. So let's see if we can actually already see the lava. We'll go to our simulation. We always need to add this as well. Again, kind of annoying, but blame the programmer, I guess. But it's really easy to, we go here, you can add the missing cases. So now we have lava. And we'll just say lava is equal to new. And it could be that maybe if we add different parameters to different particles, we might want something like this so that we could, like maybe the lava has a certain property that the other particles don't, and we need to set that here or something, which we wouldn't have to because we could just add it to the constructor of the lava. All right, so we've done that, and the mouse paint should automatically work now that we have that extra. I don't think I need to change anything with the mouse paint. All right, let's see if this lava we can get some red water basically. That's what it's going to do. So here's water. And let's just maximize this. Yep, and there's the lava. And the lava doesn't sink or anything, it just will sit on top of it's just acting just like the water. And we can add the sand. Oh, but the sand does not sink, which, again, I'll show you the code for the sinking. All right, so this is the sand system, and we have this little thing called check water. So I think in the last video, I was using the water to determine whether something would sink, but now each individual particle will have its own set of instructions for how it would sink in water. So, for example, sand will do that kind of like pyramid stacking thing. So I first check if we can put in water, and then I check for the placement. So I have another, its own special code here. And you know what? I could always put this in the cell, and then anything that would drop again, it's like this is more for the sand because the sand does that kind of like pyramid stacking. So right now this is only checking if it's water. We could do an or here, or cell dot cell type is equal to cell type lava. Now, probably if sand landed in lava, it would just evaporate. It wouldn't sink. But let's just leave that, and that should work. So let's think about this whole lava burning thing. How are we going to do that? We want it to destroy the things it touches. Uh, so maybe after it does its thing, we need to check the adjacent tiles. So we can just do a vector to up. I'm almost thinking about putting this into the cells, all these directions. Maybe uh, we we don't need call public, we could just do private. Vector to up. Now I do want to let you know, as some of these things, as I'm programming it, I might not have tested these things out. I'm just kind of uh, thinking about it as I'm coding. Um, all right, I gotta really think about this though for a second. I don't know if this will always update. Like if I put this in my constructor and I just say up is equal to position, we'll find out. Up is equal to the position plus vector 2 up, down is equal to the position plus vector down, left position is plus vector left, and then right would be position plus vector int dot right. All right, so we have this. Um, so that's pretty good, I guess. Like I said, I don't know if I have to update this in the activate, which means then I would have to run this each time, but let's just test it out with the sand. Um, what if we get rid of these? Oh, it doesn't like that. Mm, all right, I guess this has to be public. Now, there's other ways to do these kind of public and privates. You can do a setter and a getter for it. So instead of doing this as a private, you do something like this. And where is it? Oh, right here. encapsulate it. So now we have a get and a set for those things. And now we would use this to access it instead of just make this whole thing public. And then you can actually write some code in here, or you can get rid of the set so you can't change it. You can only get the information. Only the class itself could change it. But we're not worried about that. Let's just go back to our sand. So now we have that. Let's just get rid of the left. Let's get rid of the right. We're going to see if this actually works. All right, it's not working. So we actually have to set that up and down every time. All right, so yeah, like I said, it wasn't working. So do we want to do that or not? I guess we could. Um, all right, so I'm going to put it in here. Instead of writing it in this virtual activate code, each individual one would just call that. So we would just say set directions like that. So we're going to need to make sure that we always have that. Um, we should probably test this out I should probably test this out first. All right, we got some weird stuff going on here. It's acting kind of like water. All right, I just want to go over real quick the changes I made to the sand in between the episodes, as well as how I kind of improved the cell. So I have these different directions here that I've added to the cell, and we're just going to set those directions so I don't have to keep typing this every time. And this is just getting the directions for the up, down, left, right, up, left, down, right, and up, right. So when for example, in the sand, we're going to first call those directions so we can get all the directions from the current position of this cell and checking all the adjacent as well as diagonal uh, directions. So we store those vectors in those variables, and then we check for the placement. Now the check placement checks to see if there's an empty space, and we're going to send it the direction down. And this true means that we would actually remove the last position we were at. After it does that, if we weren't able to do it, then we go to the next point to check to see if there's water below us, and we have a little method here with the boolean, uh, and it checks that position, and it tries to get the cell. So what this function does, if I go to it real quick, basically it's going to check the bounds first, and then it's going to check the grid. It's going to return that grid, the cell from that grid. Now this could be null or it could be a cell. If the check bounds didn't work, it just returns a null. So then going back to the sand, we have checking to see if this is null. So this will let us know whether it's in bounds or whether or not we actually have a cell. So if it wasn't null, that means there is a cell there in that position. So in this case, the down position. If it was there, then we're going to check to see if that cell is water, and we're actually going to maybe check to see whether it's lava. And then if it was water or if it was lava, we would then swap it with this uh, this sand cell. We would swap it with the cell that we got from that grid, and then we would return true. If we weren't able to do any of this, we would just return false. So going back to this logic, we check if it's down. If it is down, then we're done. We won't check anything else. But if there wasn't water below us, then we're going to check for the placement going to the down left. and to see if there's an empty spot for the sand to kind of go to the down left. If there wasn't, so let's say there was already sand there or lava or water, then we're going to check to see if it was water or not going to the down left. If there wasn't, then we would now check to see if we could place the sand going to the down right. If there wasn't, then we would check to see if there was water going to the down right. So this is how I kind of created that logic for placing sand, whether there is water or not water. All right, so let's just see if that works. Okay, we have the sand working. Let's add some water. And now let's add the sand. All right, so you can see it's working, and I just kind of made the code a little bit easier for us later for doing other things. All right, so now going back to the lava, what we have to do is we actually don't need to, well, it depends on how we're going to do this, but yeah, this base activate, so it's going to activate the water here, and the water is already setting the directions for us. I've also in the water, I've updated that so we actually don't need, yeah. So I got rid of all these extra lefts and downs. So I got rid of those because now the cell handles all that in the set direction. So whether we use those directions or not, I just always want it to be there because whenever we make a new particle, I'll just have to say set directions and I can just use those variables. So in the lava, we activate it like water. Now we need to check each of those directions. And this is kind of why I wanted the cells to already have those positions. So let's see, we can do, um, and I might do a little comment here, check if we can burn something. All right, so what we're going to do is let's just check for the down position. So if we could say we do cell is equal to simulation dot get sorry instance dot uh, get cell, and we will send it the down position. So if cell is not equal to null. So what I really like about this function here is it checks the bounds, it checks to see whether there's a cell there or not. So really simple. So then if there was a cell there, we're going to basically remove it. All right, so let's go to our simulation, and we're going to need to add that removing of a cell. So I just want to make sure I don't have that. All right, we have swapping. So we actually want to remove that cell. So we're going to have a public void remove cell, and we will get a position. All right, so we're going to say that the, uh, let's see, we're going to say grid. You know what? We could actually, yeah, let's just do it this way. Grid position dot x comma position dot y is going to equal to null. So we don't want it. We want to also, we're going to go up to the top here. All right, let's create a new list here, cells to remove, because we don't want to change our all cells since we're looping through it, and this will remove it during the loop. We want to remove that cell later after we've gone through all of our cells. Going back down here to remove. Let's now if we want to, we could actually already send this since we do technically have it. We're going to say cell Really, we don't even need to send the position. We could just send the cell because the cell itself has a position. It should. No, let's get rid of that. Okay. So we're going to say uh, cells to remove dot add. We're going to add the cell. And we could just leave it like that. And then here in our update, we're going to do kind of what we did with the adding. Um, remove cell. So loop through all of the cells to remove. So we're doing it for each loop. And we're just going to say all cells that remove, and we're going to remove that remove cell from that list. And then we might as well just set the texture, and it would probably be better if I had like a helper. No. What's our display texture? Display texture dot set pixel, and we're going to use the remove cell dot position dot x comma remove cell dot position dot y comma, and we want the color. Now what would be better than using a hard code this color here? We might want to add a color uh, variable. So let's do that now. So here up at the top, we're going to say color, and we'll just call it the um, background color. And we're just going to set it to black. So down here, we're going to say color, background color. All right, so we remove the cell. We're going to then change the color. And we will say cells to remove dot clear. Now we could always like take all of this and put this in a function instead of having this all in the update. But we'll just leave it there for now. Let's go to this background color. Where else are we doing that kind of thing? So right here, so this is in the set position when we're changing it to the black color. We're going to change it to the background color. So this will also allow us, if we want a different color for our background, we could change that. And I think we also need to add it up here in the start function where we have where we're setting all the pixels to that black color. We're going to just change it to the background color. All right. So I think that's everything for removing. Again, down here, we're just adding it to this list of cells to remove, and then we're going to make it null right here. We could, I think we'll leave it like that. Get rid of it uh, while we have the chance. We could always like not, but do that in that loop. We'll just see how it works. So here we're just going to say simulation dot instance dot remove cell, and we're going to remove it at the and we're just removing the cell. Okay. So we're going to check if there's something there. If there's something there, we're going to remove it. And right now, everything should be burnable. Is that what can be burned? Can burn? Because that's the default setting for it. So let's see if it works. All right, here we go. Let's add some walls first, and let's see if it can burn through our walls. All right, we're just going to add some thick layer, thick. Let's just see how this works. Alrighty, let's add some lava. All right, what's going on here? Look at that. Sorry, I think it's going too fast. It's burning the lava. Okay, right here we actually have to if cell that can burn. So we have to add that there as well. So hopefully it will work this time, right? We gotta get that lava to just go right through our walls. Whoops, that's water. So here's this. Let's just test it out. All right, look at that. It went right through it. Now, if the lava and the water ever kind of sits still, it could actually do that. So yeah, it's going right through it. Um, it's kind of cool, right? It kind of it hits it and but it does kind of bounce around. Now let's see if let's just add a bunch of lava here. So we add a bunch of lava. Yep, all that water went away. And let's see what happens if we add sand to this. Because right now the sand will sink. We actually get a empty pixel here. But let's add the sand. All right, it's just burning everything, and then so I feel like it's not removing it. Maybe why are we getting that? Yeah, this is definitely not what we want. The lava should be filling in those. So we'll kind of take some time to fix that, and maybe we get rid of that whole sinking thing for the sand. So in the sand, I'm just going to remove that this right here, where if it's lava, and let me just check my null statement. All right, let me take this out, and let's see if it does anything different if I put it here instead. So it does it after the simulation. Remove cell. Let's add some lava. Okay, so the sand should uh, fall on top of and be removed right away. We probably won't see it sinking at all. Oh, it does pile up. All right, so let's see what's going on with our sand and our lava. Oh, you know what? I'm only checking the down. That's why. We got to check each of them. So, let's see. How can we do this? We're going to put this in its own little method, and we'll call this check burn. And we're going to send it. All right, let's do that. We actually want to send it a position. So instead of down, we want to say vector to int position, and we'll change this to position. That's probably why it wasn't working. We were only checking the down. All right, so let's do down. Down, up, left, and right. Let's save that. See what happens. All right, let's just add a wall here. It should burn straight through it. Add the lava. Yep. It's burning everything pretty good. It's not burning itself. And we're going to see if the sand, when it gets on top of the lava, yeah, it's just burning right away. All right, good. That's kind of what we want. And the water is. So you can kind of make some neat things here. Well, maybe not, but let's say we do this. Let's see what happens here. And then we'll do one more layer. Let's add sand in the bottom. Let's add water in here. Let's add lava. That's cool. All right, that's pretty cool. Now, we could add some kind of like burn time because it does it instantly. And I suppose Maybe lava would do that, you know. I don't know, actually. But it would be more neat if it was more of a burn time to it. Kind of like, when Gollum dropped into the lava of Mount Doom and the ring kind of sat there a little bit on top of the lava and then uh, was destroyed. So let's see if we can maybe have a timer. All right, so what we're going to do is on the cell, we're going to have a burn timer here. So private burn time, sorry, private float. It's going to be a float. Burn time is equal to 0. And private float burn max is equal to, let's just say 3. And then in our activation here, do we want to do that? We could have it here, maybe. Public void check burn. Just kind of coming up with this. Uh, let's see if burn time is greater than greater than 0. We're going to say burn time is minus equal to time dot delta time. And this just means we're going to subtract whatever your machine speed is. So this will always whatever, this is going to be like a decimal. And so when we do 3, we're basically saying 3 seconds when we do it like this. So then we want to say, so if it's there in here, if burn time is less than or equal to 0, we're now going to go simulation dot instance dot remove cell, and we're going to send it ourselves. So we want to um, we're never calling our base activation. We could always do that, but I think it might be the same. So we would actually have to go into the sand. What we could always do here too is just check for that burning, check to see if we have if we can burn. Let's just for fun, not for fun, but uh, after we've done everything for that, let's just say check burn. So the sand, the water. Again, I don't know if this is the best way to do this. We just don't want to always put that on there. So technically, if it didn't have this code, it couldn't get burned. And then the lava doesn't need a check. But here we're gonna say cell dot burn time. That needs to be public. Uh, we could not have it public, and we could just say we could make this public void start burn, and we would just say burn time is equal to our burn max time. And then in our lava, we can just say cell dot start burn. All right, so let's see if this will have it kind of slow down the burning. See what happens. All right, so here's our wall. And we're going to see if this will fill up with lava first and then slowly burn it. All right, it's not burning yet. Still not burning. I think, let's see. All right, let's see why it's not burning. All right, I think we have to check that it's not burning. So we have to actually get, well, here, start time, start burn time. Let's go to this. So we're going to just check if burn time is less than or equal to 0. So this means we're not currently burning. Like I'm trying to avoid using a Boolean to say, am I burning? Am I not burning? I can really just use this timer. So if we are less than or equal to, so I think what was happening was just restarting that burn timer over and over again. But this will say only restart it if we are uh, less than or equal to 0. So the burn time is basically off at this state, and then we're going to make it the max. Uh, so yeah. All right, let's add these walls. A little bucket here. And let's add some lava. See if we can start burning. Oh, there we go. Cool. Takes a while, but that is pretty cool. So now it doesn't do it instantly. Um, let's add that wall again, just for fun. And let's add some, actually, let's do what we did before. We'll add sand. So let's do sand here. Try to pile it up as much as we can. Now let's add water. And then we're going to add some lava. See what happens. It burned. Oh, there it goes. There it go. Oh, cool, cool. We didn't get quite there. Oh, we got some. Now this is slowly burning away. That's so cool. All right. Yeah, you gotta keep adding the lava to it because the burning isn't instant, and eventually the lava will kind of go away. Uh, well, not go away, but make its way down. So you can see this one piece of lava is slowly burning the tiles next to it. Oh, this is cool. Yeah, eventually this will, because once when it touches it, it sets that timer. Oh, that's cool. All right, so there we go. We got lava. Now what we could do is add some color indication that those things are burning. All right, so when we start burning, we can actually change the color. Color is equal to, now we could do where we take the color and add, color is plus equal to color dot, not white. I don't know. I mean, we could do red. Let's see what happens if we add red to. All right, we're just adding this here. We're gonna add some sand in this bucket. And now let's add the lava and let's see what happens with our colors. Doesn't seem to be doing anything. So, all right, so what is happening is we're not actually we're changing the color, but we're not changing the actual pixel. So we're going to create a public void set color for whatever cell we're going to send a cell. So this will allow us to just set the that texture. And so we could use this helper function for all of our other code, but we're just going to say dot set pixel to the cell dot position dot x comma cell dot position dot y, and then whatever we actually need to send a color. We're going to say color, and we'll send that color. So it wasn't actually changing that. So let's just go back to the cell and let's just do plus. Let's add this color to the material or the pixel, and then we're going to say simulation dot instance dot set color, and we are going to use this as the cell and the color. Technically, we don't have to. We could just use the cell cell color itself, but we'll just do it this way just in case. Um, we want that to not use a cell color. All right, here's my wall. Let's add some lava. There we go. Now we're getting that color. Um, let's add some sand, and the sand colors change. Oh, cool. Whoa, that's cool. So you can see that that's burn. It's on fire. Let's add some water. All right, so the color, I would have to kind of mess with the color if I wanted it to look different, but now you can see. And we could even add different things like a blinking kind of effect if we wanted to. So eventually, yep, there we go. All changes. That is so cool. All right, so I hope you enjoyed this one with lava. I think in the next episode we will add gas to the particle system so that when lava hits water, instead of the water burning, we will actually have it changed to gas. So thanks again for watching, and I will see you next time. So long.